Today's lesson is on Kangaroo Math Competition year 2013 for grade year 9 and 10. We are doing the last few questions, question 25 to question 30. In the process, we are going to cover this question. What do the three processes have in common? Factorization, completing the square, and long division. And then a special rigorous discussion, meaning a very detailed discussion on question 25. Okay, let's begin. Question 25. The numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are to be written around a circle in some order. Then each number will be added to its immediate neighbor to obtain 10 new numbers. Okay, each number will be added to its immediate neighbor to obtain 10 new numbers. What is the largest possible value of the smallest number, smallest of these new numbers? So we draw a diagram. We have the 10 numbers 1 to 10 represented by A, B, C, D up to J. So we add A, B, C, then B, C, D, go around the circle. Then we get 10 new numbers. Okay. A and B add to A and C add to B like that. B and D add to C. So you notice that every number is 3 times. B is 2 times here and 1 at the bottom. And the last one, J plus A plus B. Can see. So each number 1 to 10 appear 3 times in this addition of obtaining the 10 new numbers. So we know the 10 numbers 1 to 10, the sum is 55. And then they are added 3 times. So each number is added 3 times. So the sum of the 10 new numbers is 55 times 3 is 165. The question now is, they are written in some order. What will be the smallest, the largest value of the smallest of the new numbers? 10 new numbers, the smallest one, we want it to be as large as possible. So we do a trial and error or a simple test case. Okay, test case. I just put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in arrange in this order. Then we find the sum. So 1 plus 3 plus 2, 6. Then 2, 3, 4 is 9. 3, 4, 5 is 12. 4, 5, 6 is 15. Then we get 18, 21, 24, 27, 28, 9, 10. Then 9, 10, and 1 is 20. Then 10, 1, and 2 is 13. So these 10 new numbers, the smallest is 6. We don't want too small. We hope we can make the smallest bigger. So we have to think of a strategy, idea, how to make the smaller number bigger. The value 6 is small is because all the 3 numbers are very small. So we realize we must mix small number with big numbers, with bigger numbers. So let's put the small number 1 beside 5 and 4, and then 2 and 3. So we try to insert the The remaining 6, 7, 8, 9, 10 in between. This is bound to get bigger 10 new numbers. So the reasoning is 1 is small, so we put 5 and 4. And then 5 we put 2, 4 we put 3. We realize this 2 is 5. 1 and 4 also 5. Both are small. So we try to insert bigger number for them. So we insert 10 for this 1 and 4, 9 for 2 and 3. Then 5 and 1 is 6, so we put 8. 5 and 2 is 7. 3 and 4 is 7. But we have only 6 and 7. So we have no choice but to put 1 6 and 1 7. And if we calculate the 10 new numbers, okay, to start with this one 19, 8, 1, 10, 19. 1, 10, 4, 15. Then 10, 4, 7, 21. 4, 7, 3, 14. 7, 3, and 9 is 19. 7, 3, 9 is 19. Then we have 14. Then here 17. Here is 13. Here is 19. Here is 14. So we managed to increase the smaller number to 13. Just now, that was just a try. Now we adopt a strategy, becomes 13. Can we make the number bigger, the smallest of the 10 new numbers bigger? If we still use this strategy, suppose we examine this 2 is 7, this 2 is also 7. This is the largest already. The others is 5, 5 or 6. So they need bigger value. They need bigger value. Right? 5. Then this bigger value. So it seems we cannot do anything. This method, we still get 13 only. You put 6 here, you get 13. You put here, you get 14. So how can we come up with another idea to get a bigger, smallest triplet? So actually, the answer they give is 16, and I try. It's not possible. I can prove that. So I go and do the 15, the case, make the smallest to be 15. So the strategy is like that. We remove 10. We use 1 to 9 only. Then the new total 10 is not used 3 times. So minus 30, 135. Then the 9 numbers, 3 groups. For one group is 15. 3 times 15, 45. 1 add to 9 is 45 because 10 is removed. So we form the triplet. Only 2 ways are possible. Either 159, 15 or 168. When you use 1, you're forced to have 159, 168. 177 is not allowed. So we have 15. If we have 2, we need 13. So 6 and 7. If you have 3, we need 12. 12 plus 3, 15. 15. So this is the first way. The second way, 168, then 2 plus 13, 3 plus 12. We will now arrange these 9 numbers so that every triplet is 15. Let's arrange the first group, the one on the left. So yeah, 1, 5, 9, 2, 6, 7, 3, 4, 8. So we have 15, 15, 15. Then we have the cross border. Cross border means like 5, 9, 2, like that. A cross border, we will calculate and label the numbers. Cross border will be like 2 number add to 1 number, or 1 number add to 2 number in the crossover. So let's also realize we cannot change the triplet. If we change to some less than 15, then the other one will be more than 15. We want 15 to be minimum, so we cannot try to have 16. Then we are forced to make one of them less than 15. So no more change within the border, within the triplet, the group. All must be 15. You change only, you want to increase 16, the other one become 14. Then we notice, let's go on first. Let's calculate the 9 new numbers. Within the triplet, it's always 15. 15, 15, 15 within the triplet. 2 cases of crossover. 2 plus 1, 6, 7 cross to 3. Or 1 plus 2, 7 cross to 3 and 4, like that. Crossover sum may be more than 15, may be less than 15. Within the triplet, guarantee 15. But the crossover, sometimes you have large number, so it be more than 15. Sometimes too many small numbers, it become less. So let's have a look. This is the number. We calculate the new number, crossover enough. The within the border 15, 15, 15, no need to calculate already. So 3, 6, 9, and then cycle back 1 and 5. Cycle back at 1 and 5. So we do the crossover. 2 plus 1 first. So 5, 9, 2 is 16. 9, 2, 6, 9 plus 8, 17. Then 6, 7, 3, 16. 7, 3, 4, 14. Then 4, 8, 1, 13. Then 8, 1, 5, 14. So not good. You get 13 only. The others will be 15. Just 7 numbers already, 2, 4, 6 numbers already. We not yet insert the 10, not yet insert 10. So we got 9 numbers, 3 of them 15, 6 of them, the smallest is 13. So we find whatever is small, we want to insert to 10. We want to insert 10. We have only one position to insert. So this is hopeless. You insert, you still will get either 14 or 13. So we have got to do some shifting. So we put the smaller number in the middle strategy. 2 put in the middle, so that when you cross border, it will be bigger. Inside the border is still 15. So you put in the middle, it will be 15, 15, 15. So now the cross border will be slightly better. So let's calculate the crossover. So 196, 16. 962, 17. Then 278. Remember 2 plus 1, 1 plus 2. So 2, 7 plus the 8, 17. 7, 8, 3, 18. 3, 4, 5, 12. Then 4, 5, 1 is 10. This is okay. Why this is okay? Because only two small number. When we insert the 10 inside, they will become big. Three small number like the above, you got only one number to insert. So you cannot change all of them. So the strategy, it works by putting the small number in the middle of the triplet. So let's insert the 10. So between 12 and 10, we put 10. So now we do the crossover. Okay, 196, 16, 962, 17, 278, 17, 783, 18. Then 3, 4. Then we insert the 10. Insert 10, so 17. Then 4, 10, 5 is 19. Then 10, 5, 1 is 16. Okay, there's now the 4 and 5 in between, we put the 10. So the 12 and 10 got increased. So the rest is 15, 15, 15. There's 7 numbers already. 1, 2, 3, 4, 5, 6, 7 numbers. Plus within the triplet, 15, 15, 15. So all 10 numbers, minimum is 15. Okay, 15, 15, 15. So we can now say, this one, we can now say we got better than 13 already. Our smallest number is 15. You may also be interested in saying, if you take this second group, 168. Now we know the strategy, put the small number in the middle. So 618, 735, 924, and then 618. Then you calculate the triplet. So 16, 18, 17, 16. This too small is okay. If too many small number, cannot. The crossover must have only two small number for us to put in the 10. So if we put in the 10, between 4 and 6, we insert 10. Then we will get 16. This one 18, 17. Here is 16. 2, 4, 10, 16. 4, 6, 4, 10, 6, 20. Then 10, 6, 1. 10 join back, 10, 6, 1. So the rest will be 15, 15, 15 plus these 7 numbers. So you say 15 is the largest value of the smallest new number. I know the reason why the answer they give is 16. They did not do the arrangement. They just calculate the average only. Now prove why it cannot be 16. Now prove why it cannot be 16. Suppose 16 is the largest. Then we got 3 sets of triplet, 48. And then each number is used 3 times. 48 times 3, 144. The total is 165 minus 144 is 21. 21, we know, divided by 3 is 7. So we exclude 7. Just now we exclude 10. Now we exclude 7, then only can we form triplet sum 16 one. So 16, 1, 5, 10, or 1, 6, 9. If we put 1, 7, we're not allowed to use 7, exclude 7. So only 2 cases again. If 1 must find 10 or 6 and 9. Then we need 16, so we add 14, add 13, 14 and 13. So these are the triplets, 2 sets of triplets. We look at one of them. So the strategy again, put the middle number small, 10, 1, 5, 9, 3, 4, and 8, 2, 6. Then when we insert, we see the cross border small. 159 is only 15. We insert. Then when we insert, 9 is replaced by 7, the number becomes smaller. 3, 4, 8, 1, we put 7. So you cannot get higher than 16. Every time we see a small number, we want more than maybe bigger. Our number we can insert is 7. So impossible this proof impossible to get 16. The set show we have 1, 5, 2, 6, and 3, 4 like that. We will have all these small number maximum 8, 6 to 8. If we add 7, then maximum 15 only. It can never be 16. Okay. So 7 is too small to be inserted for this triplet. Therefore, 16 cannot be the smallest of the new number. That's the proof that their answer is wrong. Okay, we go to the next question. Using the whole numbers 1 to 22 exclusive, inclusive, or ratio wants to form 11 fraction by choosing one number as numerator and one number as denominator. Every number will be used exactly once. What is the maximum number of Horatius fraction that could have been an integer value? The fraction must be integer. So we just see prime number, we try to put at the bottom, like 7 with 14. 17 and 19, we don't have divisor. So 11, we don't want to put on top because you can use as divisor, get extra fraction. So only 2 numbers, 17 and 19, cannot have integer because 13 already used 13 over 1. So answer is 2, 4, 6, 7, 8, 9, 10. Okay. Answer is 10 out of 11, 11 pairs, 1 to 22. 11 pairs, 2 cannot. 11 pairs, 2 cannot, means 9. We count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because we don't need 11 pairs, we put 10 up there. So that 11 come down. We increase it by 1 more pair. Okay. So answer is 10. I think they also give wrong answer 9. This one. I can get 10. So 11 is not possible. Maximum 10. Next question. A 13-sided polygon is inscribed. Regular one, all sides equal length. Center O. Triangle can be formed by choosing 3 vertices of this polygon to be vertices of a triangle. So you form a lot of triangle by joining 3 points. How many of the triangle can be formed in this way have the point O inside? So you want the triangle to have the point O inside. Let's look at the diagram. This is the 13-sided polygon. V1, V2, V3 go round until V13. So we notice that it'd be very difficult to look at triangles that have point O inside. So we look at triangles that don't have point O inside. How? Just divide it into half. Let M be the midpoint. This M is here. M here be the midpoint. If we join, it will pass through O. Okay. So any triangle on the left, if we join only points on the left, it will not have O inside. But we must be orderly. We cannot just simply join. We have to know the procedure so that we don't double count. After we count the same triangle more than once. So how to have a procedure? We choose V1 first. We want V1 to be a vertex. Then V2 to V7, V2, V3, V4, V5, V6. We choose 2 more. V1 together with 2 more. So 6 choose 2. So the triangle will always have V1. V1 is always a mask array. All triangle has vertex V1. We choose the other 2. So 6 choose 2 is 15. Example, a triangle will be like that. V1 is a mask already. So 4 and 6. It can be 7 and 3. Right. So 6 choose 2. 6 choose 2 is 15. There's always have V1. Remember, always have V1. So we can use the same reasoning and say, now I always want to have V2 only. Then we join a midpoint, another line, like that. So you can repeat the counting. 15 triangles with vertex V1 do not have point O inside them. O is always outside. So we repeat this idea. You can repeat the count for V2. Then every triangle will have V2. So there's no overlap. Just now, our triangle always have V1. Now there's no V1. Always V2 only. Always V2 with the other points. So you can repeat until all the 13 points. So 13 times 15. 13 times 15. 195 triangle do not have point O inside. Okay. Now that we know the triangle do not have point O, the next thing is to calculate the total number of triangle. Total is 13 points, choose any 3 points. 13 choose 3. Number of triangle with and without O, without point O inside, 13 choose 3. 286. So we subtract all those that do not have point O will become those that have point O. Number of triangles with point O inside is 91. Okay, so again, they must develop your idea, 18. A car left point S and drove along a straight road at a speed 50. Then every hour, another car left. Each car was 1 kilometer per hour faster than the previous one. The last car, speed is 100, left 50 hours after the first car. What was the speed of the car which was in front of all the other cars after the first car left? So quite confusing, quite confusing. You got to process the information. So I tabulate at 0 hour, the first car left. Then 1 hour later, another car leave. So we write down the value. First car, 50. So if the car all move 100 hours, the 100 hours, 100 hours after the first car. So if second car start 1 hour later, but the speed is 1 kilometer per hour faster, so 51. But the duration now is less 1 hour because it start an hour late, so it only move 99 hours. So the speed times time, speed times time is distance. Speed times time. So second car plus 2, time minus 2, 52 times 98. Then car n, maybe 30th car or what, 50 plus n, time 100 minus n. Distance, speed times time, you get quadratic equation. The last car, 50 plus 50, 100 minus 50. So 100 times 50, same as the first car. Altogether, 51 cars, 51 cars. Because 50 hours, not 0 to 50 hours. So the distance is the important part, because you want to ask the speed of the car which is in front of all the cars. That means the one that has the longest distance. Which one is longest distance, like that? So in the exam, you got A, B, C, D, E, like that. You can straight away answer the question already. You can know which one is the answer already after you tabulate. But it say you want to show calculation, which car is in front after 100 hours. You look at the distance. The distance is always product of two numbers whose sum is 150. So when the sum are equal, the product will be longest one. 75 and 75 is 150. So we can answer 75 already. If n is 25, then we have 75 times 75. So if n is 25, then the speed, what was the speed of the car? So n is 25, speed is 75. Okay. But this is what called using something from experience. Experience meaning when multiply the two numbers together, the maximum is when they are equal. This you can say if y is a times b and then a plus b is always 150. We know y is maximum when a equal to b. when A go to B, we know this A, this B, and we solve N is 25. That is also one way of showing your working. But better is more theoretical one. We call it completing the square. Completing the square, we look at the distance, the general case. 50 plus n, 100 minus n. So n times minus n is minus n square. Then we got 100n and negative 50n. So left 50n. Then 50 times 100, 5,000. To complete the square, we must take out the negative sign. Coefficient of n square must be 1. Then we must also include the term 50n, which is now negative. Negative and negative is positive. And then we see this 50 divided by 2, n square. So 2 step. Divide by 2 n square. So add 25. But it's minus outside. So you actually subtract. So the value is decrease. So we increase back the value 625. 25 square is 625. So 5625 minus n minus 25 square, perfect square. This is a perfect square. So always subtract from 5625. That means 5625 or less. If you subtract 0, then it's maximum. If not, we subtract more, then it's not maximum already. So subtract 0 means subtract when n is 25. Y is maximum. So this is the way to show the maximum value. This one is from experience. But objective, of course, we want fast. That's why I must also talk about as experience. So complete the square. Why is the name called complete the square? We show if we got x square and 6x, then we draw a square. So x square, 3x and 3x. Then how to make it a perfect square? They must add here 3 times 3, 9. Complete the square. So that's why we divide by 2. If 6x, then we have to say split into 3x, 3x. So that's why we know it's 3 here, 3 here, so it's 9. If we if we look at n square and n square, because ours is negative one, so we put bigger square n, the whole thing is n. Then we subtract 25n if we do like that. 25n, because this n. Then here 25n. Ours is n square is the big one. We subtract one rectangle and then subtract a second rectangle. So the overlap we subtract twice already. 25 and 25 subtract twice. So 25 square is added. So again, complete the square. Show more example later. Next question. A gardener wants to plant 100 trees, oaks and birches along an avenue in the park. The number of trees between any two oaks must not be equal to 5. Can be any number, but not 5. Of these 100 trees, what is the greatest number of oaks that the gardener can plant? So you got to do a little bit of trial and error. So I want to put a lot of O, greatest number. Like O, 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 O. So between two oak trees, I don't have 5 trees. I got 4 maximum. So if I put one more, cannot already, so I have to put B. Then when I put B, I cannot put O again because I will have 5 trees. So force to put B, 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 B 6 times. Then O can come in. So if you try others, you cannot get that. You want O more, you must put more O one. So 6O, 6B, 6O, 6B, until you got 12 trees, 12 trees. So 12 times 8 is 96. The last 4 trees you can put oak, because the last group is B, 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 B at the end, so you can put O, 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 O. So we calculate of the 100 trees, we got 100 is 12 times 8 is 96 plus 4. So every set of 12, we got 6 oak tree. Yeah. So we got 6 times 48. 8 groups of 12. 8 groups of 12. So one group got 6 O. 6 times 8 plus the last 4. 52. Answer 52. Then number 20. The last. This is the last 5 question or 6 question. Usually got more thinking on. More thinking on. So Yoko saw a tractor slowly pulling a long pipe down the road. Yoko walked alongside the pipe in the same direction as the tractor and counted 140 paces to get from one end to the other. One end of the pipe to the front end of the pipe. He then turned around and walked back to the other end and taking only 20 paces. The tractor Yoko kept to a uniform speed, and Yoko paces were all along 1 meter long. How long was the pipe? It is good to know that you need diagram to help you visualize the description in the question. So first he walked. Then by the time he reached the front, the tractor length L. Let me. Tractor is length L. So the tractor moved to here already. Then Yoko walked 140 steps and reached the front. Okay, the pipe move. Pipe move. So then he walked back. The moment he 20 steps, he reached the end of the pipe. The pipe, this L move to here already. Okay, so as he turned back, he reached in 20 steps the end of the pipe. So this is the diagram to visualize. Start here, he walked. The pipe also move. The pipe move quite far away until when Yoko reach here, 140 steps, the front of the pipe. Then he turn back. 20 steps, then you see the end of the pipe. That means the front has gone to here, the end is here, so Yoko use 20 steps. Now how to do the calculation? We show the speed. T is speed of tractor, Y is speed of yoke, L is length of pipe, T1 time for the first part, T2 is second part where he turned back. So we got so many unknown. We try to form the equation. Y times T1 is 140. The time is T1. So the first part is T1. Y is the speed. Speed times time is the distance. Distance 140 steps. If you talk about tractor speed is T. During this time, tractor move time is T1. Tractor is here, start here. This is the tail. So tractor from front to front is the distance tractor move. Front of pipe. So D plus L only. Distance D plus L. The time is T1. During the time Yoko walking all the way. Okay, that's the first equation. Second equation, he walked back, so his speed is Y. T2, the 20 step. During this time T2, the front here go to here. So the distance is L minus 20 step. Okay, the tractor times the time. Tractor, front of tractor to the come to here. Distance L minus 20 step. So we don't need T1 and T2. We divide, divide. Just to help understand the motion only. So divide Y over T 140 D plus L. Divide. Y over T 140 D plus L. Here 20 over L minus 20. So we can equate and only get D and L. Our aim is to find L, the length of the pipe. So equate, cross multiply, cancel 7 first, 7. 14 and 2, 7. So 7, L minus 20, D plus L. So 7L minus L is 6L. Then 7 times 20, 140. So this equation 1. See, you know how to use or look for this equation because at the very start, you may have realized you already know this distance 140 step. D plus 2L 140. So can solve substitute substitute D inside here 140 minus 2L 6L 140 minus 2L, so we got 8L 280, L is 35. L is 35. So a diagram seems to be already like help a lot. If you know how to draw diagram, most likely you know how to do already, in the history of mathematics, they start with diagram, geometry. Geometry was more used than algebra. Algebra was much later, Okay. 3 common processes. What does it do? Factorization. You factorize, it become like that. Okay, 2x squared, 3x and minus 10 minus 7. 3 times minus 5. If we complete the square, the 2x squared, we take out the 2, must be 1, x squared must be 1. So 2x. 2x is half, become 1. 2x, 2 become 1, so add 1. Add 1 but 2 outside, so minus 2. So become 2x plus 1 square. What is happening? You see? If we do long division, you got the x squared plus 5x plus 1. We divide by x minus 2. How to do long division? You see x squared, you must put x and x, so here x squared. But x times minus 2, so minus 2x. Then is minus top line minus bottom line. 5 minus negative 2 is 7. Then 1 must bring down. Top line, you got 1. Then when you see 7x, you must put 7. Because here's 7x. And then 7 times 2, 14. So you subtract, no more x, so 15. So we know x squared plus 5x plus 1 is this divisor times quotient plus remainder. So what is common? These 3 processes, we say change the form of the polynomial. Without bracket, change to product. Change the form to get new information. Yeah, if you want to say form equation, then we know, oh, can factorize. So x is a fraction. You cannot factorize, x is a decimal. Okay? Like that. So information, complete the square, we can know the minimum. Change the form, it tell you in the minimum. Like that, here you don't know the minimum. So change the form to get new information. Here we change the form, we get the remainder. Yeah. So the 3 processes change the form to provide new information. Then we look at the graph. Y equal to x squared is here like that. If we do x minus 3 squared, then it move to here. X minus 3 squared. These 2 curves exactly the same one, only translated, move sideways only. They have the same shape. Okay. Then if we add add 2, the lowest point move up 2 units. X cubed just now was at 0. Now move up. The blue one is 2. Every point at 2. Like here 9 become 11. Move up 2. So the graph is still the same shape as x squared. If we got negative one, it will be like that. If we have x minus 5, here is 5. If we don't add 9, it will be inverted down here. Because we add 9, it move up to 9 units. So we got the maximum. If you this quadratic function help me answer the question just now. The car one. So when you complete the square, what do you get? Then you can find maximum, minimum. You can know axis of symmetry. Like this axis of symmetry is x equal to 5. You can sketch the graph. you can solve equation. If you put equal 0, you can get the value x. People ask, how you know it's symmetrical? You can prove. You can find inverse. All these are from 4, from 4. Formula maybe from 3 got learned, I don't know. So anyway, in future, you take note, there are so many applications. Completing the square is very, very much used. Up to Form 6 also, used a lot. This one, just now we answer already. See, I said in history, the last time like that also, they don't know how to expand, They don't do algebra one. Then they do diagram. So they draw a square so that you got A plus B times A plus B. Area, use area to understand one. Like that. So A, B, B, B. Then they calculate the area. So they find the area is here A square, and then here AB, and then here AB, and then here B square. So then they know, oh, A square plus 2AB plus B square. They don't know binomial expansion. In history, geometry start first one. Then, for example, Euclid, you say prime number. What's the prime number? Let's say the number is 7. You say it cannot be divided in any other way except 7 equal parts. Where is let's say like 12. 12 can be divided into 3 times 4 or 2 times 6. So it can be divided into 6 groups of 2 or 2 groups of 6 or 3 groups of 4 or 4 groups of 3. Where is 7? Only one way. 7 times 1. Only one way. So it's called prime number. So they didn't say it divisible by 7 and 1 only. They say cannot be divided into more than one way. Only one way to divide into equal parts. 7, 7, 1, 1, 1, 1, 7 times. That means they use diagram more than algebra. Algebra is a few hundred years later, The algebra is considered very limited, very limited. Okay, that's if a minus, then we draw a bigger square. Our A is not the small one, it's the whole big one. So we get A square. And then we draw. Then this is AB, the rectangle. Then another, this is A square, A minus B square. So you minus AB minus another AB. The overlap is, here is another AB. So the whole thing A square minus AB twice, but because of overlap, you must add back the B square overlap. So the algebra, you get the name, completing the square. Okay. All right, we end the lesson here.